In this lesson, we are going to be trying to figure out what are the 6 trig functions based on a given piece of information. So we already have 1 out of the 6, so we need to find 5 others. So they're giving us that cosine of theta is -3/5, and they're telling us that this angle that we're talking about is going to be coming from some angle in quadrant 3. Personally, I am far more of a visual person than I am a formula person. So as soon as they tell me this, I'm going to draw a picture, and my picture is going to be drawing a triangle. And when we draw our triangle, we're always locking it up with the x-axis. So this is our angle that they're referring to. I mean, technically this is the reference angle, and the angle's all the way around, but that is more than enough information. And then I'm going to label my triangle. Cosine of theta equals -3/5. Well, the -3 refers to the adjacent, and I'm going to give that piece the negative because we're going left, and then it's telling me that the hypotenuse is 5. So I need this piece because what we are about to do is sine of theta, cosine of theta, tangent of theta, cosine we already know. And then we're going to do the reciprocals. So cosecant of theta, secant of theta, and cotangent of theta. So no work to do the cosine, obviously. Secant is us just doing the reciprocal on that, so -5/3. And then the other ones, I really need the rest of the triangle. So in order to do sine, I need the opposite over hypotenuse. How could I go about figuring this out? Well, it's a right triangle. I can use Pythagorean theorem. Some of you will recognize that it's a 3, 4, 5 right triangle, so I know that thing's going to be a 4. But if I didn't recognize that, then I'm going to be doing Pythagorean theorem. So this would be a y value squared equals 5 squared. So we have a 9 plus y squared equals 25, subtract 9, y squared equals 16, square root it, and you get a 4. But I gotta be careful, I'm putting it back into my picture. Again, I know it's a triangle, and I really shouldn't have negative sides, but they are x and y values, so I am gonna have a -4 because we're going down. And then if I put the signs appropriately, everything will flow through. Don't forget that you have a smart trig class. That refers to tangent being the only positive. Sine should be negative, cosine is negative, so that's a good sign, and then tangent should be the only positive. But if you put your negatives on here, things should flow through appropriately. So sine is going to be opposite over hypotenuse, reciprocal is -5/4. Tangent is going to be a -4 over a -3, which is a +4/3. Reciprocal is 3/4. All right, so another version of this is similar kind of question where you are given sine of theta equals √2/6 and cosine of theta is less than 0. So I need to draw a picture. I'm going to be missing something, so I'm going to have to figure out one of the sides or hypotenuse or something like that. So I'm going to draw sine is positive, but cosine is negative. That means we are in the second quadrant. Now, I don't need to worry about trying to make this to scale. Just want to give myself enough space to draw a triangle. And I know that my opposite is √2, and the hypotenuse is 6. So my x will end up being negative. I just have no idea what it is. It's not a special right triangle or anything. So I'm looking to do √2 leg squared plus leg squared, which is our x, don't know, equals our hypotenuse squared. So square root of the square root and square cancel each other, so it's 2 plus x squared equals 36. Subtract 2, and you are getting an x squared equaling 34. So our x equals square root of 34. And we'll put the negative on it. All right, so let's do all of our pieces. We have everything we need. So sine of theta, we already knew was this, root 2 over 6. Cosine of theta. Cosine is going to be negative root 34 over 6. And 34 does not have any perfect squares that we would be able to simplify, so we don't have to worry about that. But that's going to be a negative root 34 over 6. And then tangent is going to be opposite over adjacent. So we are going to have we're going to do some work on this one because of all the radicals. So we're going to have a root 2 over a negative root 34. So what we can do is write this as one big radical of 2 over 34. And then my negative's just sitting on the outside. The nice thing about that is that it simplifies into a 1 over 17. And then I can reapply my square roots onto both of them. My negative still just sitting in the front. So squared into 1 is 1, so it's a negative 1 over root 17. And I'm going to come back to that step right there when we do the reciprocal, because, let me just do that right now. Cotangent is going to be the reciprocal. Well, all these steps are fair game to do the reciprocal, but this is the nicest one. Because if I just flip this, this goes up to the top, negative won't go away, and it's just the square root of 17 over 1, which I don't need. So it's kind of nice to recognize when's a good step to do your reciprocal, especially with all the square roots going on, and that's the perfect step for it. But we need to finish one more step of rationalizing the denominator on this, so we have a negative root 17 over 17. All right, whew. And then unfortunately everything else has radicals in it. So when we do the reciprocal of that, that is going to get us a 6 over root 2. We rationalize. So that's going to get us a 6 root 2 over 2, and then we can simplify that to a 3 root 2. So that's cosecant. Let's make that red. 3 root 2. And then we have secant, which is also another one we'll have to mess with. So okay. So secant is going to be, we do the reciprocal of that one, so it's going to be a negative 6 over root 34. We'll rationalize by multiplying by another root 34, which gets us negative 6 root 34 over 34. 2 goes into both. That'll become a 3. That'll become a 17. So that will turn into, still red, negative 3 root 34 over 17. All right. And then there's one last that's a little bit different than these. The picture's not wonderful for it by any means. And it looks like this, where you're finding cotangent, just cotangent. So we're not going to do all 6. We're going to find cotangent given the cosecant is negative 1.45. So you could do a reciprocal and make it into a sine, but then you kind of have some decimals, which would work. But there is another option. Some people will like it, some people won't. Some people will be like, no, I'm going to draw a picture every time. That's fine. But I wanted to show just a little bit of a different approach because some people are good with this. When you have cotangent and cosecant in the same thing, there's a property, and that property looks like this. That 1 plus cotangent squared is equal to cosecant squared. Well, they give us a cosecant value, so I can substitute it in, and I'm looking for a cotangent value so I can solve for that. So if I have that, I will do exactly that. I'm going to solve eventually for cotangent squared. Now I will talk about how we deal with that, but that'll be kind of our last step when we get our answer. So cosecant is negative 1.45, and I'm squaring that. All right, so then my next step is I'm going to be subtracting this 1 over. So cotangent squared theta is going to equal whatever this turns out to be, and I'll be putting this into a calculator, and subtracting 1 from it. So if I do that, I get 1.1025. So if I square it, subtract 1, then make that a positive, minus 1, I'll get that. Well, I still have a square on that, so I will square root that. So cotangent of theta would equal, now technically, anytime you square root both sides of a problem, you would get a plus and a minus. And that turns into 1.05. So we're almost done because we're looking for cotangent. Now how do I know if it's the positive? How do I know if it's the negative? That's where the quadrant 3 part kicks in. So quadrant 3 is down here. So hey, smart trig class. So we're down here. We're doing tangent. Well, cotangent is the reciprocal of tangent. So if tangent's positive, cotangent's positive. If tangent was negative, cotangent would be negative. Well, in this quadrant, tangent is your positive. So I want the positive answer out of this. So I have a final answer of cotangent theta equals a positive 1.05. So a little bit of a trick to this is you got to remember your formulas. You got to remember your relationships, your Pythagorean identities are what it's known as. So if you know that, this might be a very, very slick method for it. But could you have drawn a picture and labeled one of your sides? You could have turned this into sine, did the reciprocal, draw a picture, work through the problem, and you'll still get the exact same answer. So that was your 6 trig function problems.